Okay, so in the next video now, we are talking about these three trig functions. Very interesting, guys. Let's go through these three: the sine, the cos, and for sec squared. All right. So for sine and for cos, like we said, we're going to deal with them both in derivatives and in integrals. Then for sec squared, we are only going to deal with it in integrals, and then we'll deal with what produces it in the derivatives, and that is tan. So let's go and work with that. So anyway, we're going to do this now. We're looking at the next thing. So we start with sine. Let's deal with sine x, okay? What is the derivative? Remember, first we are dealing with derivatives. Okay, this is y. And then what is the derivative of sine x? The derivative of sine x is cos x. And then, let me choose a green crayon. I like green. Then we go to what would be the derivative of sine f of x? Remember, we keep talking about this guy. F of x is just something which is not x. What is the derivative of sine f of x? Once you do this, what do you create? If you say sine f of x, you create a composite function. Because f of x is going to be something which is not x. Okay, 2x, 5x squared, whatever it is, it's going to be a function. That is a function. There will be a function inside here. So when I am differentiating composite functions, I differentiate the outside first, then the inside. So derivative of sine f of x, I differentiate the outside first. Okay? And when I differentiate the outside, I don't change the inside. So if I differentiate sine, what do I get? Cos. So it'll be, okay, so it'll be cos f of x. Then what happens? Then I multiply by the derivative of the inside, but I like to put it in front. What is the derivative of the inside? F dash x. Okay? F dash x. So this is going to be what it is. Okay? The derivative of the inside times the derivative of the outside. Okay? Something like that. So now let's go to, what about if it is sine of ax plus b? Okay, because that's the one they like. Why are you doing this ax plus b? Isn't it just an f of x? Yes, it is a type of an f of x because it's not an x. So it is an f of x, right? So we still use the same thing. But I'm putting it after having shown you for all f of x's. Then we are doing this ax plus b because the syllabus wants you to know it precisely as that. But it's just a type of f of x. That's why I show you f of x first. So now what are we going to do? What is the derivative of sine ax plus b? Well, the derivative of sine ax plus b, remember you differentiate the outside sine, you get cos. Okay, so it's cos ax plus b. You don't change the inside. Then you multiply by the derivative of the inside. What's the derivative of ax? It's a. And the derivative of b is nothing. So it's a cos ax plus b. You multiply. So it's here to multiply. So it's a cos ax plus b. That is what it is. Now, that is what we do. We now come here. We are now dealing with the integrals. So this is just space, says nothing. Now we are dealing with the integrals. We are dealing with the integrals. This is what the function is. Then now here we are integrating it. So let's deal with the integral. So we are going to deal with this same guy. Okay? And if you want to integrate sine x, so if you want to integrate sine x and this, what do you do? How do I integrate sine x? So for you to integrate sine x, this you are going to take from your common derivatives table, the integral of sine x. And let me show you where you take it. You first go to the derivatives of cos. Okay, so what is the derivative of cos x? Derivative of cos x is negative sine x, right? The derivative of cos x is negative sine x. What about the derivative of cos f of x? It is negative sine f of x. The inside doesn't change, right? Then you multiply by the derivative, which is f dash x. So it is negative, can come out, f dash x sine f of x, okay? Because you now multiply by the derivative of the inside. Now, what about if it is cos of ax plus b, okay? This is going to be sine ax plus b. We know that the derivative of cos is negative sine, but I'll first put sine ax plus b. It was negative sine ax plus b. That's the derivative of the outside. Then we differentiate the inside. It's a composite function. The inside, the derivative of ax plus b is a. So it is negative a sine ax plus b. Now, we want to integrate sine. In other words, we want to integrate sine. How do we do it? You just go to where sine is on the common derivatives table and you move back. Who does it lead you to? So here, if I integrate negative sine, I get positive cos. What about if you integrate positive sine? You get negative cos. So this is negative cos x, okay? The integral of sine x is negative cos x, which means the integral of sine of f of x, what is it going to be? It's negative cos f of x, right? right? It still gets the same as this, okay? It still gets the same, but then the thing is, you then divide by the derivative of the inside, okay? There we were multiplying by the derivative of the inside. Here we divide, so it'll be negative it'll be 1 over f dash x, then multiplying cos f of x. What about if I now do sine of ax plus b, because that's the one they want you to know. What is it going to be with all this we've done? It's going to be negative cos ax plus b, right? It's negative cos of ax plus b. Then you divide by the derivative of the inside. So it's negative 1 over a, okay? The derivative of the inside of ax plus b is just a, because you differentiate ax, you get a. The derivative of b is nothing. So this is what you get. And this is going to be it for the integrals. Now let's go to the integrals of cos. This is the one to remember, okay? This is the one to remember. You integrate sine, you get negative cos, okay? How? You look here. Go look at the common derivatives table. Look for sine. Here it is. If I move back, what do I go to? Cos. And it was negative going to positive. So positive integrates to negative. That's what it is. This is what it is. This is it. This is it for sine. And we can go for cos. I mean, let's just do it real quick. Although I can see that time is flown. So let's see. What am I going to do? Now, I want to do for cos x first. What is the integral of cos x? Go look for it on the common derivatives table, sir. Okay, here I found it as the derivative. I move back. Integrating cos, what does it take you back to? Sine. It takes me back to sine. So the derivative of cos x is positive sine x, okay? The integral, rather. The integral of cos x is positive sine x. Then now I say, what about cos f of x? Well, it brings the same sine f of x, but then you divide by the derivative. So it multiplies 1 over f dash x. Okay, remember we start with the outside, then we go to the inside. So that's the same. What about for cos of ax plus b? Okay, so here's another composite function. Start by integrating the outside, so it's like the outside. This gives you sine ax plus b, okay? This gives me sine ax plus b. Then I should then divide by the derivative of the inside, which is 1 over a. So it'll be 1 over a sine ax plus b. This is going to be, then this is negative 1 over a. So these are the ones that I want, okay? So now, there we go. We've got 4 things now. We've got 4 things. We've got one more thing to do here, which is sec squared. Then after that, we just do for tan inverse. When we've done that, the guy will I mean, when you differentiate tan inverse, whatever we get, and then we're moving backwards now. So anyway, this is it. See you in the next one.